Welcome to Maths with Jade. And in today's video, we'll be looking at recurring decimals. A recurring decimal is any decimal that repeats and goes on forever and ever and ever and ever. These recurring decimals are actually rational numbers. That's right, rational numbers. And that's because any recurring decimal can be written as a fraction, making them rational by definition. Now you might be familiar with 0.3 recurring being 1/3, but in today's video we will be looking at how to convert 0.12 recurring into 4/33 and even some hard examples like 5.37 recurring and how that is equal to 242/45. And by the end of the video, hopefully you will find it simple. Let me show you how it's done. Let's begin with 0.3 recurring. Now you might know already that it's equal to 1/3, but why? And to solve this problem, we need help from our friend algebra. Because let's face it, this is your hand and this one belongs to algebra. So first, we're going to declare this number to be x. And then we're going to identify what the recurring part of this number is. And the recurring part is 3 recurring. So if we look at where the decimal place is, we can leave it there and we'll have 3 recurring after it. But I can also move it here and I will still get 3 recurring after the decimal place. In fact, I could put the decimal place here and I'd still have 3 recurring, or even here. But why make our lives complicated? Let's keep it simple. So first, if we keep the decimal place where it is, we get x, which is 0.3 recurring. And then if I move the decimal place once, I get 10x, which is equal to 3.3 recurring. Now if I minus one from the other, something quite incredible happens. So the green side, 10x minus x gives me 9x. And on the blue side, I'm going to work backwards. And 3 minus 3 just gives me 0. And then another 3 minus 3, 0, 0, 0, right until the decimal place I get 0 until I'm left with 3 minus 0, which is 3. I don't even need to write these zeros, I can just cancel them all out. And now I can just divide both sides by 9 and I get x is equal to 3/9, although I can simplify, divide top and bottom by 3 and I get 1/3. Want to have a go? Try the following. Convert the recurring decimals to fractions. Pause the video now. Let's see how you all did at that. You should have got 1/9, and then 7/9, and then 9/9. This is an interesting one because it actually is mathematically equal to 1. Now, this keeps me awake at night because how can this be true? Yet it is, you just proved it to be so. So do use it for your next party trick and impress all your friends and family. Now let's look at 0.12 recurring. First declare it x and identify the recurring part, which is 1/2. I can leave the decimal place where it is and I have 1/2 recurring after the decimal place, but I can't move it once this time because then I would have 2/1/2/1. So I'm going to move it here to keep the recurring part after the decimal place as 1/2/1/2. So x is equal to 0.12 recurring. And because I've moved it twice to keep that recurring part after the decimal place, I have 100x. And that is going to give me 12.12 recurring. And now I can simply minus 1 from the other and I get 99x on the orange side. And then working backwards again, 2 minus 2 gives me 0. 1 minus 1 gives me 0. 2 minus 2, 0, 0, 0, 0, right until the decimal place. And then 12 minus 0 is 12. Again, I do not need to write these zeros, I can just get rid of them all. Now I can divide both sides by 99, and I get x is equal to 12 over 99. And then I can actually simplify this by dividing both top and bottom by 3, and I'm left with 4 over 33. Do you want to have a go? Try these slightly more difficult examples than the previous ones, so convert the following into fractions. Be careful with part C, pause here. Let's see how you got on with those ones. So for part A, you should have got 64 over 99. For part B, 90 over 99, which simplifies to 10 over 11. And for part C, 855 over 999, it does actually simplify to 95 over 111. Well done if you did get C correct, that one was a little bit more challenging. Now I'm going to show you a super hard one, 5.37 recurring. Declare it to be x and identify the recurring part, which is the 7. The 7 repeats. So I need to move my decimal place here, and I'm also going to move it here to get the 7 after it. This gives me 10x, which is going to be equal to 53.7 recurring. And then if I've moved it twice, I'm going to have 100x, which is equal to 537.7 recurring. Now I'm going to minus 1 from the other, and I get 90x on the purple side, and that is equal to, again, 7 minus 7 is equal to 0. 7 minus 7 is equal to 0, 0, 0, right until the decimal place, and I'm left with 537 minus 53, which is 484. And get rid of those zeros. Now I'm going to divide both sides by 90, and I get x is equal to 484 all over 90, and we can actually divide top and bottom by 2, giving us 242 over 45. Now, why don't you have a go at some of these more challenging ones? If you accept this challenge, pause the video now. Let's see how you got on with those then. You should have got 66 over 90, which simplifies to 11 over 15. 933 over 99, which simplifies to 311 over 33. And then, I'm not even going to read this number out. You can see for yourself, really, really tricky, nasty number. Well done if you did part C. That was very hard. Well done, you've made it to the end of recurring decimals. This has been Maths with Jade. If you found this video useful, please give it a like and also subscribe to my channel so you don't miss other videos just like this one. Feel free to share this video and also comment below. Have a great day.